Hi everyone. In this video we are looking at multiples, factors, prime numbers and prime factors. A multiple of a number is quite simple. A multiple of a number is a number that appears in the multiplication table of a number. It appears in the times table. So for example, if I said to you, what's the multiple of 4? You will know that multiples of 4 are 4, 8, 12, 16, 20, and it goes on. All right, because these are all multiples of 4. And these are all in the 4 times table. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and so on. So the multiples you've been familiar with because you've been doing them since you were little. All right, when you were learning your times tables, that's what you were memorizing, the multiples of a particular number. If I said to you what's a multiple of 5, you will know it's 5, 10, 15, 20, 25, etc, etc. Okay, so that's nice and easy. Multiples, very easy. Next, factors. These are also easy. Factors are whole numbers that divide exactly into a particular number. So if I said to you, what's a factor of 50? You will know that 25 is a factor of 50 because 2 times 25 is 50. 2 is a factor of 50. 5 is a factor of 50. 10 is a factor of 50 because 5 times 10 makes 50. 2 times 2 and 25, when they're multiplied together, they make 50. So these are factors of 50. However, sometimes if we don't lay out when we're working out the factors, we might miss 1 or 2 factors. So I'm going to show you a way in which you will never miss any particular factor. So just one key thing to remember, multiples are bigger than the particular number. So earlier when we said what are multiples of 4, we said 4, 8, 12, 16. So multiples are the same or bigger. Factors are all smaller because we've got to multiply these together to make the big one. Okay, so factors are smaller, multiples are bigger. But back to my original question, if I had to find out the factors of 50, this is the way you need to do it. Underneath 50, you draw a big T like this, and you start with number 1. 1 times what makes 50? 1 times 50 makes 50. 2 times what makes 50? 2 times 25 makes 50. 3 times what makes 50? Nothing. We can't do that. 4 times anything makes 50? We can't do that either. 5 times 10 makes 50. 6 times nothing makes 50. 7 and nothing makes 50. 8, nothing makes 50. 9, again, nothing makes 50. And 10 is already there. If you do it this way, you just do it from 1 until 10 on the left column, and you can never miss any factors of 50. So in this example, when I started to write down the factors of 50, I wrote down 2 and 25, 5 and 10, but I missed out the most obvious ones. And lots of people make this mistake in the exams as well. They always miss out 1 and the number because they're trying to always think outside the box. Well, sometimes it's important to go back to basics. So 1 and 50 are also factors of 50, but I missed them here. But like I said earlier, if you lay this whole thing out like this, you can never make a mistake. Let's do another example. Let's work out the factors of 60. So again, I do my T shape. 1 and 60. Always start from 1. 1 and 60. 2 and 30. 3 and 20. 4 and 15. 5 and 12. 6 and 10. 7, nope. 8, nope. 9, nope. 60 is not in the 9 times table. 10 is already there. So if a number is already in this column, we don't have to write it again. So now I've got all the factors of 60. Okay, so just to remind you, this is the best way to do it, because if I just said what are the factors of 60, you'll start doing this, and we do this in lessons as well sometimes. Okay, so people start going 2 and 30, 4 and 15, 5 and 12, and then they think they've got all the factors of 60, but they haven't. They've missed out 1 and 60. they've missed out 6 and 10. Okay, so this is the best way to do it. Draw a T shape, start with number 1, work your way between 1 and 10, and if a number doesn't fall into the category, you skip to the next number. So look, when we've got to 6, we didn't have 7 as a factor, we didn't have 8 as a factor, we didn't have 9 as a factor, so we don't include it on this list. So we just have to go up to 10. Once we've gone up to 10, that should be enough. We've pretty much covered everything. So I hope that bit's made sense to you as well. So now we've done factors and we've done multiples. Okay, so just to remind you, multiples are numbers that come up in the multiplication table. If I said what's a multiple of 5, you know it's 5, 10, 15, 20, 25. If I said what's a factor of 12, right? If I said what's a factor of 12, you do the T shape, right? 1 and 12, 2 and 6, 3 and 4. 4 is already there. 5, nothing. 6 is already there. 7, 8, 9, 10. No, so we know that these are the factors. These are only these are the factors of 12. So those are factors and multiples. Now let's take a look at prime numbers and prime factors. So a prime number is a number that only has 2 factors. Okay, it only has 2 factors. So let's go back to have a look. Let's have a look at one of the numbers we saw earlier. We saw 12 earlier, didn't we? So let's write down 12. And let's just remind ourselves of the factors of 12. We have 1 and 12. We have 2 and 6. We have 3 and 4. And I think that was pretty much it. So 12 is not a prime number because it has 1, 2, 3, 4, 5, 6 factors. So it can't be a prime number. However, let's take a look at number 11, for example. Let's find all the factors of 11. 1 and 11. 2, 3, 4, 5. No, there are no other numbers which are factors of 11. And this is why 11 is a prime number. So let me say that again. A prime number is a number that only has 2 factors. And if you look at the list, those factors are always 1 and the number itself. Same with 13. The only factors of 13 are 1 and 13. 17. The only numbers which are factors of 17 are 1 and itself. Alright, so you can see that these 3 are prime numbers. Nice and easy. Okay, so the first few prime numbers, I'm going to list them here. Here we are. These are the first few prime numbers. Obviously prime numbers can go on and on. They go beyond the 100, but obviously I've run out of space. So in fact, if I was to write a few more, there are some facts about prime numbers which I just want to quickly cover with you. So here's a slightly longer list of prime numbers. Here's a few facts about prime numbers. The first fact is that 1 is not a prime number. Okay, most people think that 1 is a prime number because people think that prime numbers are always odd numbers. They're not always odd numbers, and remember, 1 is not a prime number. The first prime number is 2. And in fact, 2 is the only even number that's a prime number. Okay, all the other prime numbers are odd numbers. Okay, but not all odd numbers are prime numbers. Okay, number 9 is not a prime. It's an odd number, but it's not a prime number. 21 is an odd number, but it's not a prime number. So remember that. Just because a number is odd doesn't mean it's prime. That was the first fact. The other thing that you need to know, apart from 2 and 5, let me just delete this. Apart from 2 and 5, if you look closely, all these numbers, they end in 1, 3, 7, or 9. So all prime numbers end in either 1, 3, 7, or 9. 2 and 5 are the only ones that don't. If you look carefully, look at all of these. All right, even if I look at these few other prime numbers like 79, 67, 97, 61, 71, these are all numbers that end in either 1, 3, 7, and 9. So that's useful because if you're given a number and you want to know if it's prime, you just have to look at the last digit, and if it ends in 1, 3, 7 or 9, it's possible it's a prime number, but it doesn't mean it's a prime number. So for example, 99 ends in 9, but 99 is not a prime number because 99 is 1 and 99. Look at the factors of 99, 1 and 99, and you can also have 9 and 11. Okay, so this is not a prime number just because it ends in 9, but it's a starting point. The other thing I want you to know is, if you're given a prime number and you're not sure if it's prime, but you want to work it out, rather than trying to find out all the factors of that particular number, you just try and divide it by 3 or by 7. Right? These two numbers are really important for working out if a number is a prime number or not. So let's take a number, and let's take a number that looks like it's a prime number. Let's take, for example, let's take 91, right? Because 91 looks like it's a prime number. It doesn't. When you think of 91, you don't always think that it's going to be in one of the times tables, okay? Unless you know your times tables up to, I think, 15, then you will know. But most people have learnt their times tables up to 12, so 91 is not an obvious one. So we want to work out if 91 is a prime number. So we're going to use we're going to use these numbers. We always start with the 3. Let's see if 3 can go into 91. So how many 3s are there in 9? There are 3. Okay, and how many 3s go into 1? We can't do that. So we know there's going to be a remainder because we put a dot. When we can't do 1, we put a dot, don't we? So we know there's a remainder. And we know, therefore, that 3 does not go into 91. So it's quite possible that 91 is a prime number. Now let's try our luck with 7. How many 7s go in 9? 1 7 goes in 9. What's the remainder? 2. We're going to put the 2 over here like this. How many 7s are there in 21? There are 3. 3 times 7 is 21. So that means that 91 is not a prime number because apart from 1 and 91, 7 and 13 are also factors. This means this is not a prime number, even though it looks like it is. Okay? And I think when I say it looks like it is, you all know what I mean. There are some numbers you just think this might be a prime number. All right? So that is how you work out if a number is a prime number. You use 3 and 7 to divide that number. You could start to work out all the factors, but it will take you a while. But this is an easier way. Okay? Now let's have a look at prime factors. A prime factor of a number is a factor of a number which is also a prime number. Okay? It's quite confusing, but I wouldn't worry about the definition because I've never seen a question in an exam where they say what is a prime factor. They will always ask you to calculate it. But the more you practice, if they do ask you, you'll be able to say it in your own words. So let's take a look at an example. Let's look at number 20. Okay, so we need to work out all the factors of 20 which are prime numbers. So we would do this. We'd say 1 and 20. We would do 2 and 10. We would do 3 and nothing, 4 and 5, and 5 is already there. So 2 and 5 are both factors of 20, but they're also prime numbers. Okay? Sometimes they will ask you to express 20 as a product of its prime factor. Okay? And when they ask you to do that, this is the best way to do this. I'm going to rub this out. So when they say express product of 20 as its prime factors, this is what you do. Here's my prime number list. It's going to be very useful now. What you do is you write 20 like this and you draw a little grid like that. And you put the first prime number, which is 2, here. 20 divided by 2 is 10, and the answer goes underneath. Then you stay with 2. You keep dividing every single number by 2 until you can't do it anymore. And you only move on to 3 when you can't divide by 2. I'll show you an example. So 20 divided by 2 is 10. We're going to stay with 2. 10 divided by 2 is 5. We're going to stay with 2. Can you do 5 divided by 2? The answer is no. Then you move on to the next one. Can we do 5 divided by 3? The answer is no. Then we move on to the next one. Can we do 5 divided by 5? The answer is yes. And 5 divided by 5, we put the answer underneath, which is 1. When we've reached 1, we know that this calculation is complete. That's the first way of checking it. There are 2 ways of checking. The first way is that we end with 1 at the end. And the second way is we multiply all of these together and they should give us 20. So 2 times 2 is 4 and 4 times 5 is 20. So we know that this is definitely correct. These are the factors, these are the prime factors of 20. We have expressed 20 as a product of its prime factors. Let's do another example. Let's do 60. All right. So you can do this with me if you have a scrap piece of paper. It's all about the layout. Even in this, you've noticed almost every single maths lesson we do. If you lay out the question, if you organize the you're working out well on your piece of paper, the answer will just solve itself. Okay, but you've got to do the laying out, because if you try to do some of these in your head, you'll make a mistake. So laying out is very important. Anyway, so 60 is what we're trying to do. We're going to draw the grid, and we always put the 2 here. Can I divide 60 by 2? The answer is yes. So 2 goes there. 60 divided by 2, the answer goes underneath, 30. 30 divided by 2, we're going to stay with the 2. All right, we stay with the prime number you're on until you can't use it. 30 divided by 2 is 15. 15 divided by 2, can't do that, so we're going to move on to 3. Can I do 15 divided by 3? Yes, I can. And the answer is 5. 5 divided by 3, I can't do that. So now I'm going to move on to the 5. 5 divided by 5 is 1. The first condition has been met. I've ended with 1. So that's successful. And this is quite an important one, because sometimes, especially when we're doing this in class, in the past, sometimes we've ended with a weird number. We've ended with 2 or 4, and you know you've made a mistake in your division somewhere. Okay? Because sometimes some people divide by 2 and they forget to stay with the 2 and they move on to the 3, and then they make a mistake. So make sure you always stay with the particular prime number until you can't use it for division. So the first condition is met. We've ended with 1. The second condition is that we have to multiply our factors together. These 4 are our factors. 2 times 2 is 4. 4 times 3 is 12. And 12 times 5 is 60. I'm really confident that this is correct. Okay, this is how we double check. Let's do 72 now. Okay, so we're going to express 72 as a product of its prime factors. So the grid, like this. The first number is 2. 72 divided by 2 is 36. Stay with 2. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 2, we can't do that, so we're going to move on to 3. 9 divided by 3 is 3. We're going to stay with 3. 3 divided by 3 is 1. So we've ended with the 1, so that's a good sign. And now let's multiply these together. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 3 is 72. So we're quite confident that we've got the correct answer. Okay. A lot of people ask me why I do a T shape like this, and why that T is above this line, and why that 2 is above this line, and why. The reason I do that is because in the past, especially when I've been working it out, I end up doing this. So I do 72, and I do this, and then my first 2 goes there, and then it ruins everything. So this is more for me to remind myself that the first 2 needs to go next to the 72, and then the next 2 goes underneath it. Okay, otherwise this 2 would go there, and then each of these numbers gets pushed down, and then you end up with another number apart from 1. So this is the best way to do it. Okay, it's all part of the layout. So it's not important. This is not important. It's just to remind you that the first prime number goes next to this number rather than below it. because with all these other ones, all the other numbers are going below it like that. Okay, I want you to have a go now. I want you to work out the prime factors of 50 and 200. Okay, so have a go. Pause the video when I say so. Remember what I said. Layout. Start with the 2. Stay with the 2 until you can't divide by 2 anymore. Only then move on to 3. Once you can't do 3 anymore, only then move on to 5. And all the examples we've seen so far, they've only used 2, 3, 5. But believe me, as you get to bigger numbers, you will get to use 11 and 13 as well, and 7 as well. We haven't used 7 today yet. Okay, so pause the video now, please, and have a go. Okay, if you've had a go, your working out should be like this. We start with the 2. So this one was nice and easy. In fact, they're all nice and easy if you follow the rules. 50 divided by 2 is 25. 25 divided by 2, we can't do that. We can't do 3 either, but we can do 5. So 25 divided by 5, answer goes underneath, is 5. And then we're going to stay with the 5. 5 divided by 5 is 1. And now you can multiply this together and you will see that 5 times 5 is 25, 25 times 2 is 50. And we've ended with a 1 as well, so that's good. 200, slightly bigger number. We're going to start with the 2. 200 divided by 2 is 100. 100 divided by 2 is 50. We're going to stay with the 2. 50 divided by 2 is 25. Stay with the 2. Can't do 25 divided by 2. We're going to move on to 3. Can't do 25 divided by 3 either, so we're going to move on to 5. 25 divided by 5 is 5. 5 divided by 5, we're going to stay with the 5 until we can't do it anymore, is 1. No need to do anything else because we've ended with the 1, so the sum has come to an end. You can just double check this. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. And 40 times 5 is 200. So that is the correct answer. Now, one final thing, just to add a bit of spice, just to confuse you a little bit. Sometimes they might ask you to write the prime factors in short. Okay? If they ask you to do that, you just do this. You write 2. You write 5. And how many 5s are there? There are 2 5s. So you just put a 2 on top of the 5 like that. Okay, it's 5 squared. All right, and same thing here. You write down 2. How many 2s are there? There are 1, 2, 3. So you put 3 on top. Because it's 2 cubed is 2 times 2 times 2. 5 squared is 5 times 5. So 5 and 5. There's 2 5s there. You do a 5 like this, and you do a 2 at the top. Okay, so sometimes, not always, sometimes they'll just ask you a product of the prime factors. Sometimes they'll say write the answer in short or as an index, and then this is what you must do. So I hope this video was useful to you, and I'll see you at the next video.